base is a name given to a nucleophile when it forms a bond to H+. Therefore, base is a special case of a nucleophile because the general feature of a nucleophile is donation of a lone pair of electron towards an electron deficient species. If that lone pair of electrons specially donates towards a H+, that nucleophile will called as a base. So, nucleophile is referred as a substance which attack any other atom than a hydrogen. That means if that lone pair of electrons donate towards another atom rather than the hydrogen, because we mentioned that bases are the one that donate their lone pair of electron towards the H+. Other than the H+, if that nucleophile is donating their lone pair of electron toward another atom, those are known as the nucleophiles. So I think now you know the base is a substance which donates its electrons towards the H+. Okay, so as a base, as donating this electron towards H+, there should be another molecule which releases this H+. As of common sense, we know the molecules which releases H+ are called as acids. Okay, therefore when releasing this H+ and grabbing this H+, they are like in a reversible with one another. Okay, I think you got that point, because to grab H+, there should be a molecule to release that H+. Therefore, they have a reversible reaction with each other. In here, in this example, we can observe that because from this lone pair of electrons, it can grab this H+. That is act as a base, and this is act as a acid. So it going to form this ammonium ion and the OH minus ion. Okay, that is how a base is acting with the acid, and these two are under reversible reaction. As we know that if pK high means then the acidity is low. pK low means the acidity is high. Therefore, we know as this act as acid, it conjugate then this is its conjugate base. According to this ammonium acid, ammonia is its conjugate base. And if we consider the water molecule, this act as acid and its conjugate base is the OH minus ion. Since we know the pKa in here 10 and in the water it is 14. Since this pKa low, that acidity is high in the ammonium. So its conjugate base is weaker, since this is a strong than compared to water. Therefore, this is the weaker base, because if we have a strong acid, its conjugate base is always a weaker base. Since this is weak compared to the ammonium, its base going to be a strong base. So now you have a method to identify which one is going to be the strong base and which one is going to be the weaker base by using these pKa values. And now we have to find which way is the reaction is flavored. Either is it flavored in the forward reaction, or either way it's flavors in the backward reaction. So we have to know which way is this reaction is going to flavored. Since you are going to dealing with writing organic reactions mechanism, this concept is very important to identify which way we have to complete the reaction first. We'll look, because I told that these two are in equilibrium. Those K can be found using this equation. The equilibrium constant can be found, K can be found using this equation, that is the Ka of reactant acid. If we take this way as reactant side, this is the Ka should be the reactant, the Ka of the reactant acid divided by the Ka of the product acid. If this K should be a positive value, it should be greater than 1. Then if the K value is greater than 1, then the reaction is flavored for that direction. Because to take the Ka, because we know that when we take the pKa, if the pKa high means Ka is low. If the pK is low means Ka is high. So in here the pK is low. That means Ka is high in the reactant acid. So the Ka of the product side is lower. Therefore anyway, then we get a K greater than 1 for the reverse reaction, not for the forward reaction. So this is flavored in this path. So as a result, this reaction is flavored in the reverse reaction rather in the forward reaction. Yeah. Now we are going to discuss the nucleophile. We know that nucleophile is a substance which donates its lone pair of electron towards the atom other than the hydrogen. Normally, it's mainly the carbon atom. There's a speciality in a nucleophile. When a nucleophile is participating in a reaction, then there will be a bond formation due to this nucleophile donating electron towards this one, and there will be a bond breakage due to the leaving groups leave, which result a non-reversible reaction. Therefore, in these when nucleophile involving in reaction, not like is the base. In the base we observe a reversible reaction, that means equilibria is observed, but in here when nucleophile participating, there is no equilibria. So, since there is no equilibria in this type of reactions with nucleophile involved, to determine the strength of the nucleophile, we have to obtain the reaction rates. Therefore in the kinetics, we have to use the kinetics to find the most strength nucleophile. And also there is, other than that, there are two main factors which are responsible for the strength of the nucleophile. That is the sterical hindrance and the solvent that we use. Because the sterical hindrance means as nucleophile should attack towards a positive charge or like a carbocation, if that is more sterical hindered, that means the ability to attack will be get lower. If it is a small molecule, then it can be attacked very fastly. Therefore the sterical hindrance is responsible for the strength of the nucleophile. If we compare a like example as CH3O minus and molecule like this, and if we take a molecule like this, this basicity is high in this molecule than this, but nucleophilic strength is very low due to this more sterical hindered. This is not sterical hindered, it is easily can attack towards a electrophile, because this nucleophile can easily attack towards a electrophile, but this one cannot attack due to this sterical hindrance. And also the solvent that is used also very important to determine the strength of the nucleophile, and I am going to discuss about the nucleophilic strength in another separate video.